There we go. When solving the equation 12x squared minus 7x equals 6 minus 2 parentheses x squared minus 1, Evan wrote 12x squared minus 7x equals 6 minus 2x squared plus 2 as his first step. Which property justifies this step? Who can tell me? So how did he go from this to this? Good, Perla. He distributed. This is distributive property. Easy. Not too bad. Any questions on that? These are new ones, but they're very similar to the ones on the homework. That's the thing, is that on the homework, what we do today will look very similar to the same types of questions that are in the homework assignment. So that's why it might be a good idea to go in order rather than backwards, because then you can hit the problems that we did during class. But Jalen, if going backwards works for you, then it works for you. Okay, here's an equation. We need to know the solutions to this equation. Now, what type of equation is this? Is this linear, exponential, or quadratic? And how do you know?
I think it's quadratic.
And how do you know, Perla? You're right. And Jalen, you're right.
It's basically, I would say it's in standard form. I think if you like were to solve it and like simplify it, it would be in standard form and as an exponent, like, I don't know.
Yeah, and Alejandro said it in the chat as well. The exponent kind of gives it away. Anytime that an exponent is a 2, that's quadratic right away. So the thing is, when we try to solve, we need to solve this quadratic equation. And it's a little bit different than solving a linear equation. Because a linear equation, that's where you can basically just move things around until you get x by itself. But let's start moving things around and let's see what ends up happening. So Perla was suggesting that if we kind of move things around, you're going to get standard form. So what would you need to move and where do I move it to?
The negative 6x to the left side and the 5 too.
Yeah, both the negative 6x as well as the 5. So I can add 6x on both sides. 10 plus 6 is 16. And then the 5 as well. The 5, do I add it or do I subtract it?
Subtract.
Subtract. And what's negative 27 minus 5?
Negative.
Negative what?
30.
32. Good. Equals 0. So now we're in standard form. And if I need to solve this, so when I say the word solve, what I'm really saying is, look, I need to find the x-intercepts. That's what solving is. It's finding the x-intercepts. So in this case, we kind of touched on this like a couple of weeks ago when we reviewed quadratics, but there's a couple of different strategies that I can use to figure out those x-intercepts, those zeros. Can anyone remind me of one strategy that I can use? It sure is a formula. What is that formula called?
Are you asking for the to find the intercepts?
Yeah.
Oh, isn't it negative b over 2a?
That's the vertex.
No, that's the vertex. Never mind.
But Jalen is on the right track. It is a formula. What formula are we talking about?
Oh, the quadratic formula.
Yeah, the quadratic formula, for sure. Yeah, that'll definitely get you the correct answer. So that's one strategy that I can use. But before I use it, I always want to check to see if there's a way to simplify my equation. So do you guys notice anything that I can maybe divide by just to simplify it? Because I have some big numbers here, some 16, 32s. Is there anything that I can divide by? Yeah, Tyrone and Perla both got it. We're going to divide by 16. Just divide everything by 16, because the reason we can do this is just because if I do it to both sides, what do I still get left with on the right side? I still end up with 0, right? Because 0 divided by 16 is still 0. So let's divide everything by 16. What do I end up with?
1x squared plus 1x minus 2.
Beautiful. So now I've got some much easier numbers to work with. And remember that anytime that your coefficient is 1, I can just keep it as x. So x squared plus x minus 2 equals 0. So shall we plug this into our formula? Y'all ready? Who wants to sing?
Tyrone wants to sing.
Tyrone wants to sing. Awesome. Go ahead. Sing with me. Ready? Hold on. X equals negative 1 plus or minus the square root of
B, what's
1
B?
squared. B is 1. So let me write these down. Hold on. A is 1, B is 1, C is negative 2. So continuing on. Plus or minus the square root of 1 squared minus 4ac. So 4 times 1 times negative 2 all over 2 times 1. Okay. So now we plugged everything in. Maybe, can I erase the stuff I did at the very top? Did everyone get that down? Yes? Okay. I'm just going to erase this. Okay. And move this up. Okay, cool. X equals negative 1 plus or minus the square root. What do I get in here? 1 squared is 1. And then what's negative 4 times 1 times negative 2?
8.
8.
Ms. Lopez, what are you drinking? If it's tea, I don't want some. But if it's like hot
No.
chocolate, then give me some.
It's cafecito.
Oh, okay. Is it with leche or without leche? Is it black?
No, no leche. I like it black.
Never mind.
It wakes me up faster. If I have milk in it, it makes me more sleepy. Okay, 1 plus 8 is 9. All right, what's the square root of 9? What's the square root of 9?
3.
3. Okay, so here we go. I have negative 1 plus 3 over 2, and I have negative 1 minus 3 over 2. We got to do both of them. Negative 1 plus 3, what does that give me? Negative 1 plus 3. Anyone? Not negative 4, we're adding. So negative 1 plus 3.
2.
2, yeah, 2. And then 2 divided by 2?
1.
1. So one of my x's is 1. I can already put that in. And then the other one, negative 1 minus 3.
Negative 4.
Negative 4. So negative 4 divided by 2.
Negative 2.
Negative 2. Those are my answers. X equals 1 and x equals negative 2. Questions on how we did all that? Okay. Please remember, this is the most important thing. The word solutions. Okay, if it asks you what is the solution and you know that it's quadratic, you're really looking for the x-intercept. So make sure that you don't get messed up by that word. The solutions is the same as the x-intercepts, which there's another word for it. Does anyone remember? There's another word for x-intercepts. Starts with a Z. Zeros. All means the same thing. Alrighty. I think we have a couple more just like this. Yeah. Here's another one. So now we have x squared plus 9x equals 36. Is this in standard form, or do I need to do something to it first? It's not in standard. What has to happen? What has to move? The x has to move? Which one? 9x. Okay, well, the 9x, I could move the 9x. That's fine. However, remember that, well, what is standard form really? Standard form is ax squared plus bx plus c. So it all has to be on the same side. So it's easier to move the 36 rather than moving everything else. Does that kind of make sense? Okay, cool. So if I'm moving the 36, how do I move it? To the left. Addition or subtraction? Subtraction, good. I'm going to subtract. Okay. So this is x squared plus 9x minus 36 equals 0. Okay, I've got my I've got my standard form all set and ready to go. Let me rewrite it over here. And I can use the quadratic formula. That'll definitely work. However, I want to practice the other strategy that I could use. I'm going to write down my strategies here. I can use the quadratic formula, or does anyone remember the other thing you can do? Starts with an
Oh, never mind.
Starts with an F.
Oh, factor it.
We can factor it. So we're going to factor this. So let's practice doing that. Remember, the way to factor is that you need to come up with two numbers. Does anyone remember the pattern of those two numbers?
It's m times n. That's all I remember. I just remember the m times n.
Okay, when you multiply them, they have to multiply and equal what?
I don't remember that.
Anyone else? There's a pattern. They need to add up to something, and they need to multiply out to something. Okay, so let's review this. So this is called the sum product method. Okay, listen carefully to why. There's a reason it's called that. This is the sum product method. They need to add up to 9, and they need to multiply to negative 36. That's why it's called the sum product method. So what two numbers add up to 9 and multiply to make negative 36? Think about it.
12 and negative 3.
Exactly. They multiply to negative 36 and they add up to 9. So the magic numbers are 4, or what was it? 12 and negative 3. 12 times negative 3 is negative 36, and 12 plus negative 3 is 9. So that's how, and there's no other method other than you just kind of have to think about it. You have to think through the options and try and figure out the two numbers that work. So then once you know those two numbers, I know that my magic numbers are 12 and -3. So now when I factor, my two factors are going to be x plus 12 and x minus 3. It's that easy. Okay. So now what do? Who remembers?
Solve algebraically. So it's
Solve
basically
algebraically.
just the opposite of what you see there.
Yeah, because this would be x plus 12 equals 0. And then this one would be x minus 3 equals 0. So when I solve algebraically, I get x equals 12, negative 12, I mean, and x equals positive 3. So those are my zeros. Those are my factors. Those are my solutions. All of those words mean the same thing. So my answer is A. Questions about the sum product method or factoring? Now, you could have done the quadratic formula. If you did the quadratic formula, would you get a different answer or the same answer?
Same answer.
Same exact answer. So at the end of the day, if you prefer that, you can go ahead and use it on the test. I'm not going to stop you. Just be aware that there are two methods and you might get questions that ask about factoring specifically. So you still have to know how to do this, even if it's not your preferred method. All right, next one, another one. So now this is telling us to solve by completing the square, and we haven't reviewed this in a while, so I'm going to review this step by step, okay? Let me just reply to Eric, who's having trouble logging in.
First, we must find out x.
Okay. Well, you can't really find out the value of x. You have to actually, there's a method, and this is the completing the square method. So I want you guys to definitely write. If you haven't been writing down yet, this is the moment you guys got to write this down because the steps are always the same. Okay. So step one is just to make sure that you're in standard form. Are we in standard form? Okay, yes, we are. We're good. Step two is you're going to add C to the other side, or move it to the other side.
Miss,
So
I just remembered. This is the thing I hate from algebra. Like,
yeah, this one is tricky for sure.
proof.
I know, this one's hard, so that's why we got to practice it. So we're going to add C. So in this case, what is my C? Yes, Tara, -4. Good. So we're going to add it to move it to the other side. So this leaves me with x squared minus 6x, and I'm going to leave a little bit of space, equals 4. Now, step 3, we're going to complete the square. Now, what does that mean? What I'm going to do is there's a missing number over here that I'm going to add. Does anybody remember by any chance, we did it kind of at the end of last year, how you figure out that missing number? It's not 16. How'd you get 16 though? I'm curious. You're on the right track. You're close. It's not 36 though. I know what you're doing in your head, Perla, but you're missing a step. Okay. If anyone thinks they know it, speak now or forever hold your peace. No? Okay. So I take this middle number, this -6. I'm going to divide it by 2. That I have to do that first. So -6 divided by 2 is 3, -3. Then I square it. Then I multiply it by itself. I do it to the power of 2. What do you get?
9.
9. Yeah. That's my magic number. However, since I added that magic number on the left side, where else do I have to add it? On the right side, exactly. So I have to do plus 9 to the right side as well. So now what I have is x squared minus 6x plus 9 equals, what's 4 plus 9? 13. Questions on that step so far? Okay, take a second to write it down. Okay, step 4 is to factor. Okay, so now I have this trinomial. I'm going to factor that trinomial, and actually I'm just going to write this. You don't have to do this part, but I just want to show you guys on the right hand side. If I wanted to factor this, what are my magic numbers that add up to -6 and multiply to make 9?
-3 and -3.
-3 and -3, right? But anytime that you're multiplying two of the same thing, like if I multiply something by itself, what is that called?
Like the parentheses.
Anytime that, so for example, if I'm doing 2 times 2 or 6 times 6, what is that called?
Squaring? I don't know.
Yeah, squaring, yeah. I'm squaring it. So I can also write this as x minus 3 squared. Do we agree with that?
Yes.
Yeah? Okay. So that's all I'm doing. I'm factoring it. When I factor it, I get x minus 3 squared equals 13. Y'all with me? Anybody? Did I lose anybody? Do I have any questions? Ask them now. This is the time. If you're not sure where I got something or why I did something, this is the time to ask. Okay. Well, now, step 5 is to take the square root. Why am I taking the square root of both sides? Why am I doing that? Does anyone think they know?
No.
What is my goal again? What am I actually doing in this problem? Completing the square in order to do what? What is the literally telling me to do? What am I trying to get by itself? What am I solving for? It says solve. What am I solving for? What needs to be alone? Yeah, Tyrone, the x. Jalen, exactly, the x. X, that's my whole goal right now is I'm trying to get x all alone. But right now, that x is in some parentheses, and those parentheses are being taken to the power of 2. So I need to get rid of that exponent. And how do you get rid of an exponent of 2?
Take the square root.
Take the square root. So that's why I'm taking the square root, because once I do that, I'm left with x minus 3. I made it out of those parentheses. So I have x minus 3 equals the square root of 13. Now have I lost anybody, or are you guys still with me?
I think we're good right now.
Okay, we're almost there. There's really just one last step because I'm trying to get x by itself. What's left to do in order to get it all alone? What's left? Look at what you have. I need to get x all by itself. What is the only thing standing in my way of getting x all by itself?
The 3.
The 3. So how do I get rid of that 3?
Divide.
Not divide.
Add it.
Add it to both sides. Why am I adding it? Why do I have to add rather than divide?
Is it because it's already a negative number?
Yeah, because that negative symbol is the same thing as subtraction, and the opposite of that is to add. Okie doke, so we're almost there. We're pretty much done. The only thing is, notice how there's these plus or minus signs. All of these in the answer choice. It's all plus minus, right? The reason for that is I just forgot to write it in the previous step. But when you take the square root of a number, don't forget that you have the positive answer and the negative answer. The square root of 9 is 3, but it's also negative 3. The square root of 16 is 4, but also negative 4. So when we took the square root of 13, it's actually the positive and negative square root of 13, just to indicate that it could be both. So my final answer, when I add 3, I can't add 3 within the radical. I can't add it inside of that square root symbol, so I keep it on the outside. So I get 3 plus or minus the square root of 13. Answer choice
Ms. Lopez.
A. Yes.
I have a conspiracy theory, and I want to know if I'm right. So you know how in B and C they put 2? Did they put it because you know how you told us that in the radical when they like don't put a number, it means it's like a little 2 there and that sort of thing?
Yeah, I think they could have done that, thinking that maybe like you got confused and that's what you thought it would be. Yeah, they always do something like, you can always tell when you see a wrong answer, you can always tell what they were trying to trick you with, and that's probably what they were trying to trick you with. All right, so questions. Completing the square is probably one of the trickiest things. Like Perla said, it's one of her least favorite things. That's because it's got a lot of steps and it's not the easiest thing to remember. So make sure that you wrote this down, take a picture of the screen, because it's going to follow the same steps every single time. Same exact steps. Okay, so make sure that you remember these. And I think we're going to do one more like this. Let me check. No, this one's a little bit different, but it's similar. So let's go. Let's do it. Okay, so what values of x make the equation true? So basically, when it's asking you, like, this is such a weird way to ask a question, but it's basically telling you to solve, because it's saying what values of x would make this true? It's basically saying, can you solve for x? Solve for x. So let's try it out. So I have 2 times x plus 4 squared minus 113 equals 49. Let's solve for x. If I'm trying to get x all by itself, what should I do first?
FOIL.
Wait,
No,
distribute.
Divide by 2, and then FOIL.
Can't divide by 2 yet because that 113 is not being multiplied by 2, so I can't divide it out until I do something else. I'm not going to distribute.
We'll just add the 113.
Yeah, add 113. You want to get rid of that first because you kind of have to follow. Do you guys remember how we kind of talked about backwards PEMDAS? You guys remember that? Sad MEP. We kind of have
Wait, Miss, what did you say? You froze up.
Oh, I'm sorry. So what I was saying is we're kind of following PEMDAS, but backwards. So instead of trying to divide first, or instead of trying to distribute first, yeah, we are going to add. So we didn't need to subtract, but we did need to add.
Sad Pem.
Sad mep. All right, so I'm left with 2 times x plus 4 squared. And what do I have here? 49 plus 113 is good. Jalen's got it, 162. Okay, now what should I do next?
Boil.
No, then we divide by 2.
Then we divide, yeah, division. When you divide by 2, it eliminates that, and I'm left with x plus 4 squared. What's 162 divided by 2?
81.
81. Now, I'm trying to get x by itself. Would foiling help me to simplify this, or would foiling make this harder? Make it look even more complicated?
Oh, we're solving for x.
We're solving for x. What can I possibly do to get x by itself?
Miss,
Jalen's got it, the exponent. What can I do to that exponent? How do I get rid of that exponent? Remember, we always have to do the opposite. When you subtract, the opposite is to add. When you're multiplying, the opposite was to divide. Here I have an exponent. What's the opposite of that exponent?
square root.
Square root. That's what we're doing here. Square root eliminates the exponent. So I'm left with x plus 4. And then what's the square root of 81? 9. You're half correct, Perla. It's not just 9. What else is it?
And negative 9.
And negative 9. So this is positive and negative 9. So what we need to do is kind of split this up into 2 scenarios. In one scenario, I have negative 9. In the other scenario, I have positive 9. And now we just finish it off by solving for x. What do I get on the left side? What do I get? Oops. Anybody?
Can you repeat the question, Miss?
What do I get? Emily, thank you. Negative 13. And on my right side, five. Awesome. Negative 13 and 5. So this was basically solving an equation, but it was a quadratic equation. So that step where we had to take the square root, that was very, very important. And when you take the square root, the most important thing is that you get the positive answer and the negative answer, and you have to split it up to get both answers. Questions?
No.
This is all stuff we kind of learned back in like April. So, you know, it was when we were doing distance learning, things were a little bit weird, but I hope that this is all kind of coming back to you guys. Okay, I think I have a few more of these. Yeah, these are fun. Okay. No solution. What does it mean to have no solution? If you have a quadratic equation and I graph it on a coordinate plane and it has no solution, what does that mean?
On a graph?
What does that mean on a graph, to have no solutions? Good. It doesn't touch. It does touch something. It touches one of those things.
X.
The X, yeah. So it might have a Y. It will have a Y-intercept somewhere, but it would not have any X-intercepts. So that's what I call like when it's floating in midair. This has no solutions because it's not going to touch the X-axis ever. So that's what it looks like on a graph. But mathematically, does anybody remember what causes you to have no solutions when you're maybe sometimes you're doing the quadratic formula and you notice something is a little bit weird? Anybody remember? Like maybe you're trying it on your calculator and it says error.
If you like when it's like not doesn't make sense, like if 8 equals 0.
Okay, that's what, yes, you're correct about that. Like if you get like two different numbers equaling each other. That's one example of mathematically how you could get no solution. Nice job remembering that. I was thinking of a different thing that specifically has to do with quadratics though. And I want to see if anybody remembers it. It has to do, I'll give you a hint, it has to do with the square root. When you try to take the square root of a specific type of number. Okay, what happens when you try to take the square root of -4? What do you got?
You can't take the square root of a negative, can you? Are you trying to trick us?
I'm trying to get you to
Well,
say the correct answer. So that's the thing, is like anytime you're solving an equation and you have to take the square root of a negative, that's no solution. Okay, so for example, let's take a look at, let me pick an easy one. Let's take a look at this one. Let me pull that one out. So x plus 1 squared plus 4 equals 2. I'm solving for x. Trying to get x by itself. What needs to go away first? The 4, exactly. So I'm going to subtract it. Cool, cool, cool. What's 2 minus 4? -2. All right, awesome. And then I get to this step and I'm like, all right, cool, I have that exponent. I have to get rid of my exponent. I'm going to take the square root of both sides. And uh-oh, what happens? What's wrong with this? What's the issue?
Oh, we're taking the square root of a negative.
We're taking the square root of a negative. You can't do that. You simply can't do that. It doesn't work out. So this entire thing, no solution. You can't do it. It's over. Goodbye. So that's what I mean. So we're going to take a look at these examples, and we already know that this one is out, or this one is, we're going to select it because we're looking for the ones that have no solutions. And now let's check out all the other ones. Does anyone notice
E.
one? Which one, Tyrone?
E.
E? A, B,
E.
C, D, E. Okay. Let's do E. So E looks a little different than all the other ones. What is different about E?
It's almost in standard form.
It's almost in standard form. What needs to happen to turn it into standard form? What would I need to do in order to turn it into standard form?
Subtract 15 to bring it to the left side.
Yeah, so this would be x squared plus 8x minus 15 equals 0. Now that it's in standard form, what is the strategy I can use in order to solve?
We can either factor it or use the quadratic formula.
Awesome. And what would you guys prefer? Do you want to factor or do you want to use the quadratic formula?
Factor.
Factor? Okay. Can you
Yes.
guys think of a number that adds up to 8 and multiplies to make negative 15?
Oh. Wait, we us three thought of 3 and 5, but
But what's wrong with 3 and 5?
if you just do
It does. I
3
don't
and
think it
5,
adds up to 8.
no, 3 and 5 are 8, but 3 times 5 is positive 15, so that's not gonna work.
Positive 15, not negative. So you can't factor it. Do you guys want to try the quadratic formula then?
Yeah.
Sure.
Okay. So I know A is 1, B is 8, C is negative 15.
X equals negative 1.
X equals negative 8 plus or minus the square root of 8 squared minus 4 times 1 times negative 15 all over 2 times 1. Okay. X equals negative 8 plus or minus the square root. What is 8 squared? Let me erase all this. What's 8 squared? Anyone?
8 squared is 64.
64.
And then 4 times 15 is 60, positive 60, because negative times negative, and then over 2.
Cool. Okay, and then 60 plus 64 is 124 over 2. Okay, so we got this far. We don't really need to solve it because it's not asking us what is the answer. It's not asking us for the solution. I just need to know if this is going to have no solution. So is there any point where I would have to take the square root of a negative number?
No.
Nope. Even though 124 isn't a perfect square, it's not going to be a no solution because it's a positive number. So that one's actually good to go. Okay, that's all we needed to do. There's nothing else I needed to do. I just needed to check if this number would be negative. If that number was negative, then it would be no solution. Questions on that? By the way, does anybody know what that number is called? The number underneath the radical? Starts with a D.
Discriminate.
Yeah, discriminant.
Haha.
Discriminant. The discriminant tells you how many solutions there are. Because if it's a positive number, we know there's going to be 2 solutions. If it equals 0, it's only 1 solution. And if it's a negative number, it's no solutions. All right. Is there another one you guys know, you can kind of tell already that it might be no solution?
C.
C. Let's check it out. Okay. So answer choice C. X minus 1 squared plus 4 equals 8. What should I do to both sides to get x all alone?
Subtract.
Subtract 4. 8 minus 4 is 4. Take the square root of both sides. Am I in trouble or am I good to go?
You're good to go.
Good to go. So C is fine. That's not going to be one of my answers.
B.
Okay, let's try B. 2 times x plus 3 squared plus 4 equals 1. Trying to get x all by itself. What do I do first? Subtract 4.
Subtract.
1 minus 4 is?
Negative 3.
Negative 3. To get x by itself, what happens next? Anyone? Not square root, not yet. I will soon, but first I need to get rid of something else. What do I do
Divide by 2.
first? Yeah, first I divide by 2. Okay. -3/2. Now I want to take the square root, and am I good to go or do I have an issue? Am I good to go?
I don't think we should. I think we're bad because it's a -3.
It's a -3. You have a negative. Can't take the square root of it. This is no solution. So I found another answer. All right, one more to go. Answer choice A. All right. Answer choice A. What should I do first to get x all alone?
Divide by 2.
Divide by 2. What's 0 divided by 2? What's 0 divided by 2?
0.
Now I can take the square root. And how about here? Am I good to go or is there an issue?
There's an issue.
What's the issue?
It's a 0.
Can you take the square root of 0?
No.
You sure?
Oh. Low battery.
Uh-oh.
Uh-oh.
Try it out in your calculator. Plug it in. What is the square root of 0?
It's 0.
It's 0. So can you take the square root of 0?
Yeah.
Yeah. Square root of 0
It's 0.
is 0.
Oh, wow.
So will I have no solution?
No, you do have a solution.
I do have a solution. So this
Oh,
one
wow.
does not count. So there you go. Letter B and letter D were both no solutions. So the moral of the story, if you get to the problem, you're doing the problem and you have to take the square root of a negative number, no solution. Otherwise, you're good to go. Questions? Cool, cool. Moving on. All right. Oh, these are easy. We got to easy. We did quadratics. We're done with that. Let's move on to some easier problems. What is the value of x when the graphs of f of x and g of x intersect? So if they intersect, what is happening? What does it mean if they're intersecting?
They cross each other.
They cross each other, exactly. And so that they would kind of look like this on a graph, right?
Like an X.
Yeah. But mathematically, if they're intersecting, that means that what can I do to these two functions? Would
you like add them?
I wouldn't necessarily add them. Let me give you a hint. The point where they intersect, wherever it is, that's called the equivalence point. That's called the equivalence point. So what can I possibly do to these two equations in order to figure out the equivalence point?
Make them equal to each other?
Make them equal to each other, exactly. Because the equivalence point is the place where f of x equals g of x. We're trying to figure out where does f of x equal g of x. So what I can do is I can set these two equal to each other. So 3x plus 7 equals 2x plus 12. And now I can solve for x. So I want you guys to solve for x on your own while I go get my charger for my Apple Pencil. I'll be right back.
I got my answer, miss. I did some quick maths.
That was cheating.
No, I didn't. I'm just really good at solving algebra. Oh, miss, I just realized you couldn't hear us the whole time.
No, I just put my headphones back on.
Oh.
What were you saying?
I was just telling you that I did some quick maths, and then Tyrone told you that I was cheating, and then I just told him that I'm just an expert.
Yeah, you're just kind of
Wow.
no big deal. It's fine. Did you get the answer then?
Yes, I got x equals 5.
X equals 5. Do you want to share with the class what you did?
Sure, I'll go by fast though, because it's really not that complicated.
No, it's not.
First, I subtracted 2x, and then 3x minus 2x equals 1x, and then 1x plus 7 equals 12. Then you subtract 7 and bring it to the right side, which will leave you with 1x equals 5.
Perfect. And we know that 1x is the same as just x. So there you go. Easy, quick math. This is a simple problem. Do I have any questions?
No,
Was that a yes or no?
no question.
No questions. Okay. Next one. Wait, did I skip one? No. Okay. Now, same idea. We're looking for the equivalence point, but this time it's on a graph. We don't have to do any math. So what do I look for?
The points where they intersect?
Yeah, the places where they intersect. So look carefully. I can zoom in a little bit. Where do these two
Oh, I know.
graphs intersect?
-1, -4.
-1, -4.
Wait, for these are they asking? Oh, wait, never mind. It says x. I answered my own question.
And I heard 4, 6 from Janelle's. Yeah, you always look for the x value. When you're talking about equivalence point, it's always asking about the x values. So my x values are?
The last one and the second one.
So what are the last one, so 4 and -1. Easy. If you get a question like this on the test, you should thank your lucky stars because that should be a very easy answer. What about if it's on a table? What do you look for?
The ray, no, wait.
Where they have like the same numbers?
Yeah, exactly. Where they're exactly the same. So where do they have the same exact values?
2, 3.
2, 3. Anywhere else, or is that it?
That's it.
That's it.
Wow. I'd be happy if I got this
Easy.
question.
Yeah. Okay. All right. Next topic. What are the solutions to this equation? So what is that asking for?
Oh, I think it's D.
What did you
Wait,
look
no,
for?
A. Sorry, A. Wait, no, D. Yeah, D.
So what is it asking? Here's that pesky little word solution. The word solution kind of means a different thing depending on what you're talking about. Here, what does the word solution mean? In other words, why is D a solution?
Because it's a coordinate point on there.
On where?
On the line.
On the line. That's all it means. It has to be on the line. -3, 0 is on the line. And nothing else is. So 2, 2 is not on the line. 2, 0 is this one. That's not on the line. And 0, -3 is over here. Not on the line. So when you have a linear function, and you have to read the problem carefully, right? So this is saying choose the ordered pair that is a solution of the equation represented by the graph. So it's asking you which of these ordered pairs is on the line. Okay, notice how, let's see, did it have it over here? No, it didn't. Sometimes they'll use the word solution in this type of problem. Like sometimes they'll say, which of these is a solution to f of x equals g of x. So there's that word solution again. It keeps coming up, right? We saw solutions over here too. Solutions. We saw solutions over here. Solution. So solution definitely, it's a different thing depending on the problem. So don't think that you're always going to do the same thing when you see the word solutions. You really have to read carefully and try to ask, what is it actually asking for? Okay. All right, what about here? Which points are on the graph of this equation? What should I do to see if they're on the graph?
Maybe simplify the equation they already gave you, and then after you do that, maybe plug in each point.
Yeah, so we could simplify the equation. That might make it a little bit easier. So what would you do to simplify it?
I would add the 5 and then just add the 3 and the positive 5, and then just make it standard form.
Okay, you're close. I wouldn't want to move the 5 to the left. You'd want to do the opposite, which is move the 3 to the right to make it into standard form. Does that make sense? Because remember, standard form is ax plus by equals c. So the only thing out of place is the 3. So you could do that, Perla. That might make your life easier. You actually don't even have to do that because what you said, the other thing you said is actually going to be your best strategy, is just to plug in each of those answer choices until you figure out which ones work and which ones don't work.
Oh, so I didn't have to like do all that, just plug it in.
Just plug it right in, yeah. That's the beauty of it. I love these types of problems because they're very quick. You just plug things in and see if it works. So for example, let's plug in -2 and -10. So I would write 3 minus 6. What am I plugging in for x?
-2.
-2. And for y? -10. Okay, now I multiply, I subtract, and what do I want to happen? This actually reminds me of what Tyrone said earlier today. I remember, Tyrone, remember when you said like 8 equals 0 and that doesn't work?
Yeah.
That's what we're looking for here. What do we want to happen?
Actually, she said that.
We want it to match. So -6 times -2 is 12. 2 times -10 is -20. And now we do some math. 3 plus 12 is 15. And 15 minus 20 is -5. So -5 equals -5. Are we good to go? It's equal, exactly. So that one is a solution. And now we would go down the line and do each and every one until we figured out which ones work and which ones don't work. I'm going to do one more together, but then I'm going to go to the next problem because if you guys understand how to do it, then there's no point in doing all of them right now. So for B, I would plug in -1 for x, +1 for y, and we're going to do the same thing. -6 times -1 is +6. 2 times 1 is 2. 3 plus 6 is 9. And 9 plus 2 is 11. So what happened here?
So that doesn't make sense.
Does not make sense. So this would be no solution. That's out. And we would go down and check every single one, do it a bunch of times until you find all the ones that work. Do I have any questions on the strategy or what we need to do?
No.
Awesome. All right, moving right along. All right, so now for the function f of x equals 2 to the power of x, is 5, 32 a solution? So this is very similar, but my function is no longer linear. What type of function do I have here? What type of function is this? Quadratic, Linear, exponential, or something else?
Something else?
I think it might be exponential.
How can you tell when you have an exponential function?
It has an exponent.
And what is that exponent going to be?
X.
X, or t, or n, or any variable. Okay? So yes, this is exponential. And they want to know if this is a solution. So we can pretty much do the same thing. We can see if it works out. So what would I plug in to this function? Which of those numbers am I actually plugging in?
The
5.
The 5, yeah. Because remember, that's the x value. So I'm going to plug in a 5, 2 to the power of 5. And what do I want it to equal? If this is a solution, what should this equal?
32.
It should equal 32, but we don't know. We're going to check. We're going to see if this actually does equal 32. So 2 to the power of 5, what does that mean I need to do?
Multiply 2 by itself 5 times.
Exactly. So this is 2 times 2 times 2 times 2 times 2.
30.
Does that equal 32?
Yes.
Yes?
Yes.
Good. 2, 4, 8, 16, 32. 32 equals 32. That is a big old check mark. Yes.
Ms. Lopez, I have a question.
Mm-hmm.
Will they put these things like this in the ELC where we have to explain?
Mm-hmm. So I was just going to ask, what would be a good explanation? How would you describe what we just did? You can use any.
5 is 32.
Yeah, you could write 2 to the power of 5 is 32. You can
I
say.
also have a question.
Mm-hmm. Go ahead.
You can finish first, though.
Oh, I was just going to say a different way to say that could be when you plug in 5, you get 32. You know, you can use your own words. What was your question, Tyrone?
Is the ELC going to be written or online?
Online.
Okay, thank you.
Mm-hmm. Alrighty. Another one. Oh, this is actually more similar to what we did at the beginning. So now, consider the function f of x equals x squared plus 6x plus 8. Rewrite the equation to reveal the zeros
Easy
of the
peasy.
function.
They want us to factor it.
How do you know? You're right. How do you know?
Because in
0.
the factor form equation, that's when you can tell the zeros.
Exactly. So what I want to do really quickly is just summarize what each form actually tells you about. So for example, first of all, how did you know that we were talking about quadratics again?
I just thought it was standard form, and then I remembered that you can make it into vertex form or factored form.
But more specifically, how do you always know if something is quadratic or not?
Oh, the exponent.
Exponent.
The exponent is 2. Okay, good. So I want to talk about the 3 types of forms. We have standard, vertex, and factored. Each of those tells me or reveals a different thing. Perla just told us how factored form reveals the zeros. It tells us the zeros. What do standard form and vertex form reveal?
Standard reveals the y-intercept and vertex reveals the vertex.
Good. And that could be something very useful if you want to take a picture of this or write it down.
Okay.
Just to remember that what each form tells you. Okay, so factored form is the only one that can reveal the zeros. So we need to factor it. That's all this is asking us to do. We need to find a number that, what is it? The sum product method. So what do those 2 numbers need to do? Sum product method. What are my magic numbers? Anybody? Did I lose everyone? What's going on?
Oh, we're still
I was
writing.
still writing.
Oh, okay. Gotcha.
Okay, we're done. I don't know about everybody else, but
Okay. So now let's actually do what we need to do. We need to factor this function, this trinomial, which means I'm going to use the sum product method. So what do my two magic numbers need to do?
m plus n need to equal -6, and then m times n need to equal 8.
Good. So what two numbers add up to -6 and multiply to make +8? Add up to -6.
Negative.
7.
Actually, wait. Yeah, -2 and -4. Yeah.
-2 and -4. Good.
I went
Negative
for a second.
-2 plus -4 is -6. -2 times -4 is +8. So there's my magic number. So my factors are x minus 2 and x minus 4. And that's it. That's all we had to do. So now I can go ahead and I can rewrite it. F of x equals x minus 2 and x minus 4. Questions on this one? All right.
No question.
No questions?
Nope.
Okay. How about here? Select all the equations with equivalent zeros. So we need to figure out all the equations that have the same solutions, the same x-intercepts. And let me quickly just take a look at my other. Okay, good. We only have one more problem after this. We're good. All right. So they need to have the same zeros, the same solutions. So there's kind of a lot to do here. So let's pick the ones where you can easily figure out the solutions. Which of these answer choices can I very quickly figure out the solutions for? And remember, zeros mean the same thing as solutions, x-intercepts. Okay, so make sure we remember. So which of these are in a form that reveals the zeros?
D and then
A.
not A.
D and
I'm not sure about E. I'm kind of eyeing it, but
what form should it be in? What is that form called?
factor.
Yeah, factored form. Factored form. E is definitely in factored form. Or sorry, I meant D. D is definitely factored. Is E in factored form?
Yes.
For
Yes.
sure. Yeah.
Oh, so it doesn't matter that it has like the slope.
That's not a slope.
Oh.
It's not
That's
a
a fact.
slope. It looks like a slope, but it's not. So yes, that's factored. What's the first two in? The A and B?
-7 and
Quadratic.
I'm sorry.
They are quadratic. All of these are quadratic, but what form are they written in? The first two.
Oh.
Good, Jalen. Standard. How about C?
Vertex. Wait. Oh, yeah, vertex.
Vertex form. Okay. So they're each different forms, but the ones that are obvious are the ones in factored form, because what are the zeros for answer choice D? What are my zeros? 7 and 2, but don't forget we need to flip them. So it's actually what? It's not positive 7 and positive 2. It's going to be yeah, they're going to be negative. Because remember, it's always flipped. And I'll show you why in the second example, in the next example. So negative 7 and negative 2. Okay. Now D, very similar, but don't forget the reason that in the previous one it was negative 7 and negative 2 is because really what we're doing is we have to set these equal to 0 and then solve for x. So when I solve for x over here on the left side, what do I do to both sides first?
Miss, you lagged out. Can you repeat it?
Sure, what do I do to both sides? I'm solving for x.
Subtract.
Subtract 7. So I have 1/2 x equals negative 7. How do I get x by itself?
Divide.
But I have a fraction, so I'm not going to divide
By the opposite reciprocal.
just by the reciprocal. So what's my reciprocal?
Oh no, not the opposite. Oh, 2 over 1.
2 over 1.
2 over 1. So I'm multiplying by 2. Negative 7 times 2.
Negative 14.
Negative
Wait.
14.
Oh, yeah.
So I got negative 14. And then on the other side, same thing. I'm going to subtract 2. 0 minus 2 is negative 2. I divide by 2. So what do I get? Negative 2 divided by 2, guys. Let's go. Sleepy. Sleepy heads, wake up.
1.
Negative 1. Okay, so far these don't match. So we got to look at all the other ones. Okay. All right, we have 5 minutes. Let's kick it up, guys. We're falling asleep. I'm falling asleep, and I had coffee.
Wow.
You guys are putting me to sleep. Okay. If I have standard form, if they're in standard form, how can I figure out the zeros?
You can either factor it or use the quadratic formula.
Factor it or use the quadratic formula. So let's do, I don't know, let's do quadratic formula for A. A is 1. B, do I have a B? There's no B, so that's 0. All right, so let's plug it in. So x, I'm going to do it down here. X equals negative B, negative 0, plus or minus the square root of 0 squared minus 4 times 1 times 14, all over 2 times 1. 0 is just 0. Negative 0 is just 0. So 0 plus or minus 0 squared is just 0. Negative 4 times positive 14. Anyone?
56, negative 56.
Negative 56 over 2. So this is 0 plus or minus the square root of negative 56 over 2. What's the problem?
It's a negative.
It's a negative.
You can't square a negative.
So this is no solution. So we know that one's automatically out. Let's do the same thing with B. Answer choice B. We know A is 1, B is 9, C is 14. All right. Here we go. X equals negative 9 plus or minus the square root of 9 squared minus 4 times 1 times 14 all over 2 times 1. This is negative 9 plus or minus the square root. 9 to the power of 2 is 81.
81.
Sorry, I cut. And then we already know that 4 times 14 is 56, right?
Yes.
Okay. 81 minus 56.
25.
25. What's the square root of 25?
5.
5. Oh my
5.
God.
And remember, we have positive and negative. So this is negative 9 plus or minus 5. So we have to add 5, and then we have to subtract 5. So when we add, what's negative 9 plus 5?
4 over 2, which is equal to 2.
Negative 9 plus 5, though. So that's negative 4
Negative 4.
over
My
2,
bad, I'm sorry.
which is negative 2. And then when you subtract 5, what's negative 9 minus 5? Negative 14. And negative 14 divided by 2 is negative 7. So we got x equals negative 2 and x equals negative 7. Ooh, which ones match already? Which ones have the same zeros?
B and C.
C?
Wait, no, D.
D. Okay, so we already know these are out. Now we have one more. We don't really have time for it. This is in vertex form. So long story short, this one would take a while. Maybe we'll have time tomorrow because tomorrow's class is a little bit shorter. So if you guys remember this, remind me to do it tomorrow, okay? But we got through pretty much everything, so I feel good.
Yay.
All right, 10 problems tonight, 10 problems every day this week. You should have 50 by Friday night, and if you haven't been doing your homework, you better kick it up because you better have 50 done by Friday. Otherwise, that's a lot of F's in the grade book. This is not the time to slack off. You got to do the work if you want to do well on the EOC. All right, y'all. So that's all for today. Good job to those who participated. You did great. I'll see you guys
Yay.
tomorrow.
Bye.
Bye, miss. Have a great day.
Thank you. Bye.
Or afternoon.